So, hello and welcome to today's Satoshi's 21 seminar session organized by the Bitcoin Munich community. With our events, we address not only hardcore Bitcoiners, but also a more general tech audience from our region. I saw a lot of signups on Meetup, so welcome everyone in whichever way you join us. The format today is not a presentation, but perhaps more a mix between a panel, an open discussion, and a lighter version of the Socratic seminar, popular among many Bitcoin developer meetups around the world. And this basically means that we go through material online and we discuss what we see. We'll be discussing consensus mechanisms today, cryptoeconomics and threat models, and what makes Bitcoin Bitcoin. Does Bitcoin have shortcomings? Can Bitcoin be made better? And what does it actually mean to make Bitcoin better? We're hoping to clarify these questions today. And so we've invited two very special guests because a lot of the material today comes from them. They'll surely have a lot of similar views, but maybe there'll also be some that differ. We will see, but maybe it's mostly just about terminology. We will see.
I'm sure Eric and I can find things to disagree about.
Okay. So Eric, want to introduce yourself?
I'm Eric.
You're Eric.
I'm a maintainer for LeBitcoin, C++ Bitcoin Developer Toolkit, started by Miyazaki in 2011, full client node server implementation. I write about cryptoeconomic theory. It started out as a wiki on our software repo, and in January, last year, in February in Vietnam, I had a conference called Cryptoecon, and put that wiki out as a book for the conference. And then I got around finally in January this year to publishing that, an edition of that on Amazon. So, and there's a free PDF and a Kindle book. And just recently, in the last month, I've got it started back on working full time on the Bitcoin development. And that's it, I guess.
Cool. Bob, do you want to introduce yourself?
Sure. I apologize. I've had tremendous problems with video, but apparently audio is working. So I'm Bob McElrath. I've worked for a number of companies in the space. Most recently, Fidelity, helped get Fidelity Digital Assets off the ground. Before that, I worked for the SolidX, the guys behind the Bitcoin ETF the last time around. There's several new ETF proposals out now. And now I'm essentially freelance, advising a couple startups and working on basically whatever the heck I want to.
Okay, sounds good. Did you two actually meet each other already?
Many times.
Okay.
Many times. Yeah, I invited Eric up to Boston for a presentation at Fidelity back in the day. I'm a fan of LibBitcoin. I haven't really found opportunity to use it, much to my own dismay, but he and I have talked at length about it. I think we also met in Hong Kong, I think more than once. But yeah, Eric and I know each other. In Milan, yeah, Milan.
We first met in Hong Kong, and then in Milan, and then somewhere else, and then in Boston at Fidelity. Yeah. We worked together on Bob's braids proposal, which he introduced in Hong Kong. And I was very interested in that. We ended up having a couple of conversations about it. And then he created a working group to discuss that and other aspects of trying to resolve the inherent mining pooling pressures, as I call them, variance and proximity.
Yep.
Yeah, we will go over this today too and find out what the state of this is. But so to get the ball rolling, the first topic would be does it make sense to look beyond the use case of money, and is it necessary to optimize for them? Here we have an example of blockchain narratives coming back with a German digital health passport that writes hashes are not one, but 5 blockchains. Have you heard about that? And what's your opinion on blockchain or technology behind Bitcoin in general? Maybe you want to start, Bob. Maybe you still have to in your profession refute these questions.
I was surprised to see this article. And in fact, in the little list of links you sent out, I added another link after that, which is from CoinDesk, I think, saying from a number of insiders at IBM that their blockchain project is basically dead on the inside from IBM. So they've gone through several years now where they've missed their revenue targets by like 90%, and there's been a number of reorgs and a number of people have left, and it sounds like IBM is a shell of its former self, and IBM blockchain is dying. This has happened to a number of companies. State Street bet heavily on Hyperledger about 3 or 4 years ago, and then about 2 years ago essentially fired the entire team. And so there's a whole lot of Hyperledger developers out there who formerly from State Street. Now there's a whole lot of former IBM Hyperledger developers on the market, and very, very few actual projects. So the fact that Germany apparently bet on this surprises the heck out of me.
IBM has better salespeople than technology people sometimes. I work for them.
Yeah.
1980.
I think that's true. They have better salespeople than technology people. Look, I think that the use case here, the digital health passport. What they're trying to do here is take the. If you guys are familiar, I know in Europe you have these little yellow booklets that show your vaccinations and stuff like that, and just making those records digital. That's a valuable thing to do, right? Especially in the days of COVID, and people are going to ask you to prove that you had the vaccine when you go someplace. At the end of the day, I don't think this is something that needs a blockchain. There's an authority who decides these things. They run a server, they run an API, no big deal, right? It's easy to do. You don't need a blockchain. You don't need all this lingo and mumbo jumbo. You just need to go to the official, API and ask, does this person have a vaccine? It should be easy.
Yeah, I mean, it's the central problem with most blockchain ideas is that if what you're securing is not like Bitcoin, just the information that's on the chain, right? Then it's kind of pointless because there's always some enforcing authority outside of the chain, and you might as well just go to them in the first place.
That's right. And remember that the primary use case of blockchains is censorship resistance, right? So whenever you see something like this, you should ask yourself, well, what is the chance of censorship and what are the consequences of censorship? Now, is anybody going to censor your proof that you had a vaccine? Probably not. There's no money to be made by doing that. There's no case there, right? So Bitcoin is a very heavy technology. Blockchains are a heavy, expensive technology, and you pay a lot of costs in terms of latency and things like that to get that censorship resistance. But this is something that does not need censorship resistance. It is fundamentally centralized around a health authority or a medical provider. Just go ahead and use that medical provider.
The censor is the state, right? And that you have a passport. The state's enforcing the passport, right? They don't need a censorship-resistant solution for your passport.
That's right.
And those yellow cards you refer to, those go back to yellow fever. I did a little research on this a while ago. Yeah, I assume that's why they're yellow. But those are international, not just Europe. I have one. I got it because I was traveling so much, and there are a couple countries. So there's, interestingly enough, there's only one illness or communicable disease that will prohibit your transit across national borders anywhere in the world, and that's yellow fever. Still to this day, probably because they created those cards. Some countries you can't enter, some countries you can't leave. I don't know. There's only a few. There's a couple in Africa, maybe a couple in Asia. And so it's not a new idea. It's like an addendum to your passport. And back in the day, when those yellow cards were created, the passports, passports didn't even exist until World War I. And they looked very similar, to kind of the little passports. It's just passports evolved and the yellow card kind of died out. So yeah, we're working towards kind of a more formal, it seems anyway, passport system for things other than identity.
Yeah. Well, so one thing about this is that applying cryptographic technology to something as fuzzy as biology, in my opinion, doesn't make a lot of sense, right? I mean, there's definite value in having these yellow cards, but at the end of the day, the thing it's measuring, which is basically the number of people that have been vaccinated, is a fuzzy measure in the first place, right? Sometimes people get vaccinated and the vaccine doesn't take. Sometimes people can't get vaccinated, right? And we're relying upon herd immunity. So having cryptographic proof that you got the vaccine is not absolute proof that you don't have a disease or can't transmit a disease or won't get a disease. So, you don't need cryptographic strength records for this kind of thing, in my opinion. What you really want are like large scale statistics and health studies rather than, proof that any given person did a given thing.
Yeah. But in terms of blockchain, I mean, the only useful scenarios that I've seen for, Bitcoin technology is money and time stamping. And, you might want your timestamp to be censorship resistant. You might want to, be able to prove something to somebody that the censor can't change. But again, the only information you're securing is the information that's on the chain. You're not securing anything else. So it's not entirely the information on the chain. Like, for example, property, deeds. Putting the deed in an immutable timestamp doesn't really help you if the authority that you're trying to resist, the censor who's trying to change your deed, is the one who enforces it in the first place.
Absolutely.
So the whole idea is kind of pointless. There's a chapter on that I wrote about back when blockchain was the thing. Now we have blockchain art, proof of ownership, and again, who's the enforcing authority, right? Do they care what's on the blockchain?
No.
So Michael, where do you want to take us?
Yeah, this just added 2 links to or just one article on one paper by the Cambridge Alt Finance organization. They call it the blockchain meme, or blockchain as an excuse. It's already a few months old, or one or 2 years. I think that's an interesting paper for those who want to take a deeper look at that. I mean, these are all things that are quite known to us who've long been in the Bitcoin space, but I thought maybe we would bring this up for an audience that's not yet so familiar with these questions. Do we have actually questions or remarks from the audience?
Has anybody read this? I didn't read it. This is from 2019. Is there a newer version?
I'm not sure, but it's last I found on a quick.
I thought we were discussing moonshots for Bitcoin today. Did I get the wrong day?
Let's do moonshots.
Or are you coming on to that?
Right. Yeah.
It's coming up.
I mean, the theme is maybe it's a moonshot. Maybe these are valid use cases, right? I mean, who wouldn't want vaccinations on the Bitcoin blockchain?
Me.
Oh, I see. You're saying this is a moonshot. Okay.
Yeah.
Or rather, okay.
Yeah. I mean, every time we have a big price spike, we onboard a lot of people, and everybody seems to have to go through the same questions each cycle.
Yeah.
So good to cover some old ground sometimes.
That was the idea, somewhat. Yeah, this is, and so when we're talking about, you already mentioned.
Oh, Andrew. Yeah.
Now the digital art is a thing, and yeah, this is also a very old paper by Andrew Prostra, treatise on altcoins. I recommend very much everyone to look into that. and that you should not, altcoin developers are maybe often a bit irresponsible because they're building completely new crypto system. Are you still familiar with these papers, anyone, or Bob or Eric?
I've read it many times.
Yeah.
I agree with basically every word.
You got to realize you're talking to a shitcoin developer here.
Really?
And it's not me.
Okay.
Wait, who's a shitcoin developer?
You ran a shitcoin for a while back in the day, didn't you, Bob?
Oh, I did, yeah. Don't tell anybody about that.
That was back before anybody knew what a shitcoin was. So
that was back before Ethereum launched.
Exactly.
Yeah.
I think Eric brings the whole paper to the point.
I have to have clear definitions for these things. I'm not really sure if you worked on a shitcoin, Bob. What was the basis of it?
This was a coin for rewards points, like hotel points or airline miles, things like that. This was a business that was started around that. They no longer use it. I think they've switched to IBM Hyperledger, ironically. But yeah, I forked Satoshi's code and put some interesting things in there for that use case. That was kind of the first paid job I had in this space. And I will say one thing here. While I don't like shitcoins in general, the fact of the matter is a lot of people have cut their teeth and learned things from doing this. Now, the coins themselves, I think, are worthless, but at the same time, contributing to Bitcoin is very, very hard. And forking the entire code base and having your way with it is a way to learn your way around a system. And so I think a lot of people follow this path.
Yeah. Amir took I don't know if anybody else has ever done this approach, but Amir's approach with LibBitcoin was not that, a lot of people assume LibBitcoin is a fork. It's not. It started with one CPP file and grew from there. And it has no code from Bitcoin Core in it. It did at one point. It had a couple classes, but I tell you what, that's a way to learn Bitcoin. And I should also say that I have no philosophical problem with altcoins, and that's why I wrote that shitcoin. I read a number of things about altcoins, split coins, and I wrote that shitcoin thing there because I had to. Most of this stuff is for me to get things clear in my head. Most of the things I write, and part of it is just making so I have to retype it, in Twitter repeatedly. But I was like, okay, there's got to be some clear distinction here between what's a shitcoin and what's just an altcoin, because LibBitcoin supports, we started out by modifying the code base so that we could, through config changes, only allow people to run testnet, right? Just change, you can run two processes off the same binary. One's testnet, one's Bitcoin. Why recompile for testnet, right? And then we added reg test, and then somebody came along and wanted to fork the code for Litecoin. And I'm like, Litecoin is literally 2 lines of code different. You're going to fork 500,000 lines of code to get 2 lines in there. And so we put in configuration for Litecoin reg test, and Litecoin testnet. So now we have 6 coins we support just through config changes. And then I generalized that to supporting. Those are just forks, right? So we have a config file for each rule change. So we just added more rule changes. And so you can turn on, BIP XYZ. You can turn on or off any rule you want. And that's very useful for running, for testing against soft fork compatibility, right? You rerun the whole chain with the soft forks turned off. And if it doesn't sync, something's wrong. And learning how they behave. So in doing this, I had to make a decision, like, what's the difference between a shitcoin that I really, I don't want to bother supporting, and an actual useful coin that's just different in some way. And that's why I wrote that quick shitcoin chapter. And to me, the distinction is there's a class of coins that all conform to the principles laid out in Satoshi's paper. I mean, Litecoin could be, the implementation. You change, time value, you change a constant, and all of a sudden it's a shitcoin. Now So I had also defined those principles, which I call cryptodynamics, right? These three principles that essentially are the security model and design of Bitcoin, not just from a tech standpoint. And if something pretends to be, to have those capabilities but doesn't, then I call it a shitcoin, right? So any proof of stake is a shitcoin because it's not censorship resistant.
Well, I completely agree with you, and I'm not opposed to altcoins either, really. I mean, there is a time and a place to do experimentation, and we need experimentation. We need people to try new things. Satoshi didn't get everything right, and things have changed since then. There's a lot of new stuff out there. I mean, like the tech on zero knowledge proofs has gone through the roof recently, right? And yes, we should look at that stuff and apply it, as well as things like new hash functions, new signature algorithms, things like that. So we need experimentation. I think long term, I think most of the altcoins out there, including Ethereum, are going to be remembered as the playground where people learned something. But I've had a conversation with many altcoin developers who say, "Oh, I have this great idea. I'm going to make a coin." Some of these you may have even heard of, and they want to talk to me for some reason because I've done things like this. And they say, "Well, okay, so how do I secure my coin?" And then you have to have a very hard conversation with them because there are no good answers to mining a new coin, right? I just built a coin and I want to mine it. So people see it two ways. Either I go mining or I go proof of stake. If I go mining, then either I put myself in a class of hardware where that set of hardware that could mine my coin outside the coin is much larger. So consider, for instance, Zcash and Ethereum, right? There's more hash power mining Ethereum than there is mining Zcash. And if somebody wanted to 51% attack Zcash, they could co-opt a bunch of Ethereum mining hardware and vice versa, right? This is something I call the external majority. You can have most of your hash power not committed to the system. So the day you create an altcoin, you have to somehow have all of the hash power committed to it. And Bitcoin achieved that over time, right? Most of the hash power that does SHA-256D out there is committed to Bitcoin. But if you wanted to get that today, starting from scratch, it's very hard, if not impossible, which is one of the reasons people go down this rabbit hole of proof of stake. I think longer term, if you really wanted to do it, the answer is to create a new hashing algorithm and create an ASIC to go along with it and develop some kind of fair distribution of that ASIC so that you can achieve wide distribution of the ASIC. I think that's the only answer. And nobody wants to hear that because that's like a $100 million project right there.
Well, or I mean, certainly I agree that the hashing algorithm has to have a change. It doesn't have to be a new hashing algorithm. Well, I mean, some aspect doesn't have to not be SHA-256 or something, but some aspect of the algorithm has to be different. It
has to be that the hardware used to mine Bitcoin or any other coin cannot be moved between coins. That's what you really need to achieve, right? The actual algorithm is pretty unimportant.
Right. Just can't already exist in mass production. And another approach is you just start small. I mean, like, take another algorithm like Script, like Litecoin did, and you just start small. So whenever anybody's trying to reverse is not worth it, right? That's still where Bitcoin is, right? It's the same situation Bitcoin's in. And, you go back 5 years ago, we were having these conversations and Bitcoin was way weaker than it is now. And anything weaker than Bitcoin, people would call a shitcoin, but Bitcoin is now, the old Bitcoin is now much weaker than the new one. And everything goes through these phases. And I could certainly see somebody just doing a low volume coin that it's not worth attacking because it's not carrying much value. That's the resistance against double spend. And to build up resistance against censorship, you have to get bigger than that. But again, it's not worth it to the censor if you're small either. And this is the whole process Bitcoin has gone through. And I think other coins can go through that without a major investment up front, like you're talking about. I think they can just start small and grow, and they're just too small to attack. Because
I think they could, but they've all made the wrong choice, right? So if you want to make mining and you want to do mining as good as Bitcoin, what you want is a very, very simple algorithm like SHA-256 or SHA-3, right? And what you're looking for is a way to couple that coin's production to an external resource, namely energy. And you want it to consume as much energy as possible. Every other coin out there has gone in the opposite direction. They want to consume as little energy as possible. And this is basically a misunderstanding on I think, every coin's part. There are two numbers in mining, right? One is capital expenditure, and the other is operating expenditure. The one that creates decentralization is high operating expenditure and low capital expenditure, right? Every single coin has gone the other direction. They said, we're going to make it memory hard. We're going to make it use storage. We're going to make it, use GPUs. They're increasing capital expenditure and decreasing OpEx, which increases centralization.
That's a good observation. I mean, I look at it as, from a higher level, there's only one expense. There's expenditure, right? And breaking it down into the two aspects of that expenditure. So the expenditure doesn't need to be, it will be the reward, right? Whatever the block reward is, that's what the expense will be. And it will get divided up among those two things as you described. And I think it's a really good observation. It's very clarifying to say that CapEx versus OpEx is really the central aspect of decentralizability. That's a great observation. And you remember Chia?
Yeah.
Bram Cohen's thing?
I've talked about it many times, yeah.
Yeah, you and I have talked about it, I think, in the past. And when Chia came out, they raised like 25 million bucks, and then they hired a bunch of PhDs, and they went to work, and they wrote a white paper, and then they announced. And after they announced, I quickly scanned through the white paper and skipped over all the math, and I went, well, it's not a shitcoin, right? The idea was not a shitcoin. It's a Bitcoin.
There is something genuinely interesting there. So Bram has built this, like what he calls, I think, proof of space-time, where he's using storage and then filling the storage and using that as essentially your mining. But it's the same essential concept as memory hard. Like, we're going to use another resource, and we want the cost of that resource to be zero. And I completely disagree with that. I think many of these altcoins have bought into a narrative which I think is completely false, and that narrative is Bitcoin wastes energy. And so one of the things I wanted to say today is that narrative is completely false. And in fact, I want to make the case that Bitcoin is actually green technology. Why? I think the Bitcoin community has kind of taken this criticism and kind of said, well, yeah, but the good that comes from it is worth it. And I think this is completely untrue. It's actually green. And the reason it's green is that it is a consumer of energy, right? Why do you need a consumer of energy? Because energy is not produced in a uniform manner. It's not produced in times and places where you need it. And as we move forward with more renewable resources, solar and wind and whatnot, those energy resources are produced in times and places where people don't live. You put wind farms in the middle of nowhere, solar farms in the middle of nowhere. A lot of people, went to proof of stake with this because of this misunderstanding, thinking that we were wasting or burning CO2. We're not. What we're going to see in the future is more and more renewable resources coupled to Bitcoin mining, because Bitcoin mining is the buyer of last resort. And if you're a wind farm in the middle of nowhere, you need that buyer of last resort because your consumers are far away. You're producing at the wrong times, and you need a method of arbitrage in the market that allows you to sell your power so that you don't go bankrupt. We're going to see a lot of wind farms and solar farms go bankrupt because they can't sell their power because in the wrong place and it's at the wrong time. So one of the companies I'm advising we're working with is doing exactly this. So putting Bitcoin mines on site with energy producers. And I think that's long-term what we're going to see. And it fundamentally greases the wheels of green deployments.
We should have Steve Barber on the call.
Yeah,
I'm gonna. Let me see. I'm trying to. Sorry, I was trying to bring up a link for him. I don't know, Mike, if you can find it. But Steve Barber's company's called OHM, OHM. He told me at one point he named it OHM because it's a symbol, engineering symbol for resistance, and he liked it. The idea of the axiom of resistance in the book.
I thought it was upstream data.
Well, he's got two brands. Yeah, there was Upstream Data and there's OHM, which is, maybe it's a brand on his product. But he gave me he spoke at the conference and he gave me a ball cap with OHM on it. And I thought that was pretty cool. He's great and understands these things very well. And he's one of those people that's out there making hardware for vent mining. Anyway, the point I was trying to raise with Chia was, I looked over that paper and I realized, okay, this is Bitcoin where you're shifting the expense to to CapEx and capital expense. And what they didn't realize, after doing all the math on space-time, was they were going to consume the same amount of energy. They had to, right? The energy was going to be consumed producing if you got to the same block reward as Bitcoin, BTC, they would end up consuming the same amount of energy manufacturing, shipping, disposing, installing hard drives. Like, there seemed to be this assumption that people would just use the hard drives they already had, use the free space they already had. But the reality is, in order to, if people were only using what they had, there would be no expense, right? Yeah. And so
I have made that argument.
Right.
I've made that argument directly to Bram, and he didn't buy it.
I made it to him on Twitter, and a year later I made it to him again. As soon as the paper came out, I told him this. I made it to him again a year later, and he blocked me. About a year after that, this is, I don't know, about 9-12 months ago or so, one of his PhDs contacted me directly and said, "We've finally come to the conclusion that you were right." And they said, the team is pivoting. We're looking at proof of stake. And I was like, yeah. If you don't want to consume energy, go to proof of stake, but you're not going to be censorship resistant. So the conclusion was pretty obvious that, but how do you miss that, right? Like, if I'm sitting here and I have a hard drive, I'm going to make 100% profit. So is everybody else, right? As the block reward increases, we're just going to continue to make more and more profit. So the assumption is nobody's going to go out and start manufacturing hard drives in mass to capture this profit. And of course they have to.
That's not true, right? Somebody will.
And so, it's the problem of not looking at these things as economic questions, right? There's some engineering aspect of this that tends to make people myopic when it comes to the economic aspects of it. And you need both. So, and I completely agree that shifting from energy, which is a ubiquitous, resource, to something like hard drive production is not a benefit in terms of being able to hide decentralization, right? You have a small amount of hardware and you take it wherever there's energy. You can go anywhere, hide anywhere. Unfortunately, CapEx comes into play when you're looking at a lot of renewables, wind and solar primarily, because you can't mine profitably unless you're on 24/7. So you end up with hydro and geo, which are not very mobile, and or oil, which is better. And that's kind of been Steve's take on it. Is this is a great, this is the way it works, right? This is everywhere in the world. We have burnable sources of energy, which will get burned anyway, right?
Well, one of the motivations behind using something like hard drives, it's the same, I would say, mistake as Satoshi made. Satoshi said, well, what's a resource out there that everybody has so that I can get ready to use the system? So one of the problems you have if you create a new technology like this is bootstrapping it. I want to get it in the hands of many people as possible and have them be able to contribute usefully to it by mining or whatever, right? So in the early days of Bitcoin, it was using your CPU. And the fact that everybody had a CPU was important. Later on, people said, well, okay, so everybody has GPUs. Let's do that. And, Chia said, well, everybody has hard drives. Let's do that, right? This is a means to get it into as many people's hands as possible by making it cost them very little because they already have the asset, right? But at the same time, if you don't spend anything to get something, it's not worth anything, right? That which what's the statement? That which is nothing risked, nothing gained, right? If you don't actually put up any capital to get it, it's not worth anything to you, right? It wasn't until Bitcoin reached its industrial scale and people started putting in data centers full of miners that it really became a utility grade, energy proxy asset and really became an asset. Before that, it was just a toy.
Yeah. Well, had Satoshi been able to solve the problems that you and I worked on in terms of variance and proximity, his approach, and I don't know. Early on, I'm not like a deep, long-time Satoshi reader. I haven't tried to consume everything he wrote, but I don't recall him early on writing about those issues as the centralization, the pooling pressures that they are. And had they not existed, his theory would have held up, right? That you earn on a percentage basis. So you can be a very small miner, put in a very small amount of capital, and earn your percentage. And that would be great.
That's the goal. That's not the reality. Yeah.
That's what we want. That is the holy grail of Bitcoin. And
we'll get to that, I think, in a section or two.
It's one of, to me, it's one of the two things that. So when I talk about a lot of time, people ask me why did you write all this stuff? How'd you get into it? And I wanted to know what we were working on, why we were working on it, what would work, what wouldn't, what was worthwhile. And as core developers, not just Bitcoin developers, but as core developers, I came to the conclusion that our job is to improve the security of the system. And the two things that stand out the most to me are privacy and pooling or centralization. I refer to mine pooling as pooling of miners as pooling, and I refer to pooling of validation as centralization. I just have to have a word for each, right? But people generally refer to them both as the same thing, and they're not. But as centralization is this other aspect, and on the mining side, pooling, it's a major issue. On the validation side, it's a usability issue in a way, right? But it's easily solved. But it's not going to exist unless people are hiding, right? If it's all white market, there's no real need for people to decentralize their transaction processing. Nobody's attacking it. But it can be. That problem is not an engineering problem to solve, aside from maybe improving interface and design, which is one of the things I work on, trying to get tools that into people's hands where they can actually build Bitcoin stuff, not set up a server where I can validate everything for them. So on that side, I think the technology holds up. On the mining side, it doesn't. Right, the theory behind it doesn't hold up. And I think. So
do we want to get into that? Right. So there's several tabs here that are essentially around proof of stake that kind of fall under the heading of shitcoinism. Do we want to talk about proof of stake, or do we want to dig into pooling and grades and stuff like that?
Yeah, first because we talked previously a little bit about experimentation, and Adam Beck tweeted a while ago. If a really significant innovation would be found, then Bitcoin could adopt it. But the question would be if it really would be so easy, because we're seeing currently, of course, the debate about taproot activation. So, what's your opinion on that? Would it really be so easy to migrate to a completely different system and importing the UTXO set into the new system or code?
I think the presumption is incorrect, and Adam, I don't know. Adam seems to have over the years evolved into more of a promoter of BTC than a technologist, and I find that a little disappointing. I'd really like, to me, the technology and the economic opportunity is what matters, not making sure that everybody who's got a stake in BTC continues to grow their stake. That's not what I care about. And whether or not, enough people will accept a rule change to do some feature in BTC, it's not, and really there are no changes. Every time a rule gets adopted by a bunch of people, it's a new coin. The question is only whether everybody goes along with it or not. If they don't, you have a split. That can happen with a soft fork or a hard fork. So it's not about changing BTC. It's about creating new coins and getting everybody to go along with you. And if some technology that people want to adopt comes out in a split coin or a new coin, great. And if it's significant enough, it can become valuable or more valuable than BTC. I don't adhere to this one true coin, idea. I understand there's a network effect and it's hard to overcome, which is great and important. But technology is going to keep moving forward. Implementations will keep moving forward. Things will change, and the market will adapt. And this is happening, like Bob was saying, that the altcoin communities are a great place to experiment on these things and learn things. And maybe BTC will fork off into another coin that has some of these new features, and everybody will go with them. That's great. Or maybe it'll split and create another chain. That's great too. It's we get down to it. Why do we care about these split things? There's only two reasons to care. One is people are getting scammed. It's a shit coin, and people are lying to them about its behavior, or people are hodling and they're really just here to get some free capital gain out of it, which I really, it's not what's important to it. The interesting aspect, the important aspect of it is that it does growth in price of BTC drives interest and people into the community and gets them started, which is what's happened every time. Yeah, it's happened every time there's been a big price spike. We get this big influx of people that are interested. I got involved because I was very interested in what happened with the Silk Road it wasn't over yet, but I was very interested in that. So the press, informs people and lets them know what's going on. It's a great aspect of it, but yeah, I don't bite my nails over whether I can get a feature into somebody's coin or not, and get them to fork off onto this new feature. That's not important.
So specifically about this tweet. So first of all, Adam, the first thing it says, I don't believe this. So I think you might be misreading it there, Eric. But nonetheless, what's described here has been done many, many times. It's called an airdrop, right? You've seen many coins that have airdropped, values in various different ways.
Yeah.
And by and large, this technique hasn't worked, right? It's a way to get user base. And I mean, how many of you held on to your airdrops? Probably not very many. Most people just sold them immediately. Now, what he's really describing is like, how do we, get changes into Bitcoin? If something really important came along, the thing about Bitcoin changes that Bitcoin has so far gotten right, and almost every other coin has gotten wrong, is the continuity. It's the soft fork. It is the backwards compatibility of it that is what enables Bitcoin to, move forward. Anything else is basically a hard fork or a new coin, right? You can do hard forks, you can do new coins, and we've seen how that's happened over and over and over again, thousands of times, from Bitcoin Cash to, Litecoin to all kinds of things. It's always worth less. The one that has the backwards compatibility, that is the preferred feature over everything else. Backwards compatibility.
I would make. I mean, to me, this gets a little bit theoretical, and I lose people. But there are no backward compatible changes to rules, right? There are changes that you can make that you can. I mean, if I apply a soft fork to my box, and I start accepting that money, other people try to, I try to give that money to other people, and they'll reject it, right? It's a fork. They will not accept my money. The thing with a soft fork is that if you get majority hash power enforcement, which is a 51% attack, then you can force people whose nodes haven't changed to be able to still accept the old money. They still can't deal with the new money, right? If you don't take SegWit transactions, you don't take them, right? Nobody can force you to do that, but you can still process the old ones. So every rule change is by any altcoin definition a new coin, and
I think that's semantics at some level. It's true.
It's important when it comes to these discussions on activation, because what people think is they can activate the rules without that majority hash power enforcement, and it will still be backward compatible, which it won't. They will split the chain, and it's just, and so many people have come to believe that, and people who really should know better, core developers with years of experience, have been telling people that will not split the chain, that it's backward compatible. Soft forks are not backward compatible. Minor enforcement of soft forks brings people along. So you have a choice between a hard fork, which is, if you want everybody along, you have to have 100% of people decide to go along. If you have a soft fork, you can get 50% of the people that are mining to go along, and you can drag those other people along, still being able to use the old coin. So using soft forks with majority hash power support is a way to advance while kind of keeping the community together. But
it's a way to achieve backward compatibility. And whatever mechanism whatever technical mechanism you use, it's the backwards compatibility is the thing you want to achieve, one way or another.
And that's the only technical mechanism that anybody's come up with, right? There is no other way in Bitcoin.
As far as I know. Well, no, actually, I'll bring up another one called the feather fork in a little bit here when we start talking about trades.
Yeah, but there's a rule change, and either it's a soft fork with hash power enforcement, or it's a split, right? And there's no other way around that in Bitcoin. And people have tried to split that baby and say, well, no, we can do this without the hash power enforcement because it's a soft fork. Like, no, that's a split. And I had this discussion back when SegWit was going on, and people were talking about splitting, and I'm like, great, but don't tell people that it's not a split. I even had Adam came up on Twitter. We had a long discussion about this, and I came out and I said, why don't we just use BIP9? There's really no reason not to, and now they're doing it. But in that discussion,
because everyone has PTSD from the SegWit activation, that's why.
Right, because I predicted this back when that happened. I said, you're learning the wrong lesson here. And he actually said that SegWit missed its activation window, which was off. That was an error by 2.5 months. SegWit activated 2.5 months before its activation window closed. And then we were discussing, the fact that, some subset of the community could activate their rules without majority enforcement, and it wouldn't matter. I said, yeah, not until a miner mines in SegWit, mines a taproot invalid transaction, and now you have a split. They said, well, they wouldn't do that because of relay policy. I'm like, relay policy, that is not. If they run
the code unmodified as provided by Bitcoin Core, only.
So all somebody has to do is submit a transaction to one of these miners who's not enforcing the relay policy, that's SegWit invalid, and boom, you got a split. Who's going to stop that, right? You're relying on relay policy to prevent your whole chain from splitting.
You have to rely upon majority hash power, and that's why BIP9 requires majority hash power to signal, because it is that hash power that is enforcing those rules and ensuring that old nodes don't see invalid transactions.
But to be fair, it's not ensuring. It's improving the probability, because miners can.
As long as it's actually the majority of the hash power, it's ensuring, right?
The signaling is not the implementation. You can signal and then not enforce.
That's right.
So you're relying on the fact that if you get up to 50%, you're relying on the miners, signaling honestly, because they realize that they might be in the minority if they don't. So it's a little bit of a gambit, but it's proven to be very effective. And I've also heard people say that BIP 16 was what we call user activated, and it wasn't. It was it was just not fully automated, right? And because it wasn't automated, it had some problems. So then we automated it. But miners signaled with a supermajority, and then people activated. They did not do it absent that signaling. So there's a lot of false information being put out by people who have, a desire to do things or a desire to demonstrate who's in charge. And the reality is the technology says that if you want compatibility, miners are in charge. It's the tech. It's nothing else, right? The point I go back to originally was that every rule change is a fork. We call soft forks forks. They split the chain if you can't get people to go along. And calling other forks that split the chain and add some rule shitcoins is, to me, irrational.
It's all about backwards compatibility.
Right. But Bitcoin has had hard forks. It's recently had hard forks, and people just ignore them because people go along. There's been 2 hard forks since SegWit. One was
I'd like to move on. I'd like to move on from this topic. We could talk about taproot activation forever. I think everyone is negotiating with their own fear on this topic, and I don't know. I've chosen to stay away from the topic by and large because I'm just tired of it. And the answers are simple, but nobody wants to. The
overarching point, which was an answer to Michael's question, is that changes will happen. It's not always all about getting BTC to go along. or core dev, Bitcoin core developers to go along.
Yeah, and let's not play this game of who's in charge, right? Everybody's pursuing their own rational self-interest. Miners are not our enemies. Miners are self-interested parties who don't want to shit where they eat, right? So they're not going to go do something crazy, as a lot of people think.
Well, I will definitely agree with you there. I mean, and a miner, if I was a miner, I have no responsibility to anybody else to do anything but do what I want. That's the whole point, right? You don't owe anybody anything. They invest their own capital. They mine,
If we don't have a system that works solely because of rational self-interest, we don't have a system that works, and we need central control, and then we've destroyed the entire thing. So let's just go ahead with it. Everybody pursue their rational self-interest, use BIP9, and get it over with.
Good. Maybe someone else wants to do a quick remark about this. Otherwise, we move on.
Can I ask a question in the chat? Gak asks, so what would happen if and when SHA-256 is broken and Bitcoin needs to change its mining algorithm to survive? How many hash functions are there currently?
Lots.
And how many?
Well,
lots?
Technically, there are an infinite number of hash functions. You have a couple different classes of hash functions. So SHA-256 was followed by SHA-3. Designing a good hash function is actually very, very hard. A lot of people regard that the current iteration of hash functions, namely based upon the Merkle-Damgard construction, are probably secure, hopefully forever, but you never know. Anyway, so SHA-3 would be another good choice, and we could switch to it, and we could use a longer hash function. Another thing to note is that you can put an extra piece in the pre-image, and that's technically a different hash function. So A concatenated with whatever you're doing, hash that. B concatenating with whatever you're doing, hash that. Technically, each of those is a different hash function. So, that's why I say there are an infinite number. There are a finite number of classes that we know about, but it's easy to pick another hash function. The hard part is maintaining continuity if we were forced to do a mining algorithm change. Because obviously the old code cannot accept headers with a different mining algorithm.
Yeah, and I'm not the cryptographer here, but I don't believe that you really need a new hashing algorithm to change
He was asking about SHA-256 being broken.
Oh, that's a different issue. I was referring to the mining algorithm, right?
And he said the question was asked regarding bootstrapping a new mining ecosystem for a new blockchain.
That's the mining algorithm, right? That's not about the security aspect of it. So that could be another implementation just using SHA-256. But if SHA-256 is broken, then obviously you have issues on both mining and security aspects of Bitcoin.
To directly answer your question, Gak, what needs to be done if SHA-256 is broken is a very hard question that I don't really want to get into right now. That would suck.
There's been a good, just to refer you off, there's been a bunch of research done on, what do you call it? It's what essentially amounts to hardening the chain against, God, I'm forgetting the term, advanced crypto, looking at the different aspects that depend on the assumptions of SHA-256 and other hashing algorithms in Bitcoin, and people have identified what are all of the issues that would need to be resolved and what could be done in terms of creating a new coin that mitigates those issues.
It's a lot of work. It's very hard. It's very disruptive, and I don't think that work is going to get done unless there's a clear and present danger on the horizon.
I agree. It might get done, but it won't get used.
Yeah.
Okay, then let's move on. We already talked about proof of stake a bit. This is, of course, also one of the canonical papers, also from Andrew Perstra on Stakeon and consensus. And Bob wrote an article also several years ago around the time frame where you probably put this also into more succinct form. Do you want to go quickly over it, Bob?
Not really.
Not really.
I just texted out a link to my proof of stake topic as
Yeah,
well.
Yeah, we have it also in the list, of course, because
I didn't, when I looked at proof of stake, it took a while, actually. I wasn't bothering with it. And then I finally, there's so many things going on about it. I finally took a look at it, and I came to what was a very simple conclusion based on the other concepts that I'd already written about, which is that it's just not censorship resistant. I don't care about any of the other technology aspects or, facts that, things that people write about, which all may or may not be true. But the fact is, the censor is the state. Or at least you can just assume that that's what you're resisting. You're not resisting people like miners, who all miners censor. They choose the transactions they want to for whatever reason they want, right? But the point of it is that another miner can choose transactions for whatever reason they want, and they can still get mined, right? Somebody with 51% and who's willing to lose money can censor. But the point is that in a proof of work coin, which relies on external input to provide the ordering authority, more energy can be added. Where with the proof of stake coin, once you have 51% of the stake, you own the coin. It's internally focused. And there's only two types of securing these coins. There's internal to the chain and external. And if it's internal,
the internal,
you own it.
Internal just doesn't work, right? So the one of the mistakes in this article that I wrote that the proof of stake community makes is that I can see all forks, I can determine which one is the correct fork, and I can punish those who don't do the right thing. All of this is wrong because the punishment itself occurs on the chain, right? If I create a fork, the guy who forks the chain is not going to vote for his own punishment, right? He might be punished on a different chain. And the fact of the matter is, you can create as many forks as you want. The failure mode that Ethereum and all the other proof of stake coins seem to sweep under the rug is that I can make 10,000 forks, right? If I have the keys to last round's a set of stakers or validators, right? I can create a fork at that point. And then I'll publish 10,000 forks. I'll put them all over the web, on every website. I'll send out emails saying, use this chain instead of that chain, right? And then everybody's going to be confused, and the whole thing just falls down. And to Eric's point, this is a form of censorship resistance or lack of censorship resistance, because if I'm attempting to censor the correct chain, or what somebody else determines as the correct chain, I can do it through confusion, right? I just create a whole bunch of chains.
Or you can just on the single chain, you can reject transactions that you don't want because you're the majority. You don't have to accept them. Yeah. And the point is, the fundamental point is, there is no way to remove that authority. With proof of work, you can add energy and therefore remove the authority. And it took me a longer time to figure out who pays for that, right? Satoshi never said it. He actually, I think, implied once that the community would have to band together and donate to the cause to get the censor out by mining at a loss. Doing anything at a loss is economically irrational. Bitcoin has to be irrational to withstand censorship. It has to be rational to function economically. And it's rational to pay a higher fee when your transaction's not getting confirmed, which is what people already do. And so by paying a higher fee for your censored transactions, you incent more energy to join the system, more miners who are willing to take the risk of doing it illegally and maybe push the censor out, and everybody's getting paid at the same time. The censor then has to operate at a loss, tax revenue, right? That's where censorship resistance comes from. If you're the censor and you just go invest a bunch of money in buying up enough of the coin, proof of stake coin, to become the censor, you've already, you're the state. You're accepting that you're going to take a loss on it. And how does anybody get you out? They can't. There's no way to do it. So proof of stake coins are simply not censorship resistant. And there's a number of ways to explain it. I chose to, the simplest possible way I can is that once the censor has 51% there, they own the coin.
They don't even have to get 51%. All they have to do is obtain the keys for any previous epoch of consensus.
Yeah.
And then they can create a fork.
Well, it doesn't even matter what percent it is, right? Once I think I didn't refer to it as 51. I referred to, it's just simpler to say it that way. I referred to it as controlling amount, right? Well, whatever that coin requires for whatever reasons, once you get to that level, you don't have to let anything change on the chain. right? There's nobody
But
to change
that can cost nothing, which is the nothing at stake problem, and that is that old coins that no longer control assets may not be worth anything and may be easier to obtain, right? And you don't actually have to buy the coin. So the thesis that you have to buy the coin in order to stake isn't untrue. If I can obtain old keys from old staking addresses, right, I can do the same thing.
And even if you did have to buy it, the presumption is, so there's two aspects of the security model in Bitcoin. One is guarding against double spends, which is not about censorship resistance, right? That when somebody's stealing, that's an attack. Censorship is something that miners all do. It's not an attack. The question is whether you want somebody to be able to prevent you from getting your transaction confirmed. And that, the presumption there is that it's the state that doesn't want this money to be operating without permission. They're the permitting authority. And the state is perfectly willing to operate at a loss to make that happen because they're protecting a revenue stream that's external to this. They don't care about the loss. So if your whole security model depends on the stakers, or the miners, right, in Bitcoin, not taking a loss, and that's what's going to secure your coin. You're confusing double spend security with censorship resistance. That's right. Yeah.
There's a whole lot of circular arguments in proof of stake. I'll point out another one just for fun. It's impossible for a system to prove its own internal self-consistency, right? And this, you might say, goes back to Gödel's incompleteness theorem in math.
Yeah, that's a good one.
And proof of stake is the assumption that I can prove the internal self-consistency of this system using only the system itself. And this is mathematically impossible. You have to make reference to something external in order to do it. And what does Bitcoin make reference to externally? Energy. It's energy input to create the hashes for the chain going forward. What does a proof of stake coin do? What does it reference externally to prove its own consistency? The ability to Google the current block hash. Now that is very censorable, right? This is called weak subjectivity.
It's also not internal. It's external, right?
It's not internal, right? But there has to be something external, right? And this is what Vitalik calls weak subjectivity, and that is I somehow, through social means, can determine what the current block hash is. And social means are very subject to censorship.
Sure. Yeah, it's impossible as long as it's as complex as Pinot arithmetic, right?
Yeah.
All
right, let's move on. I'm tired of talking about proof of stake. I'm willing to let it just die on its own. We can go round and round forever on this, and it's been around forever. And there's always an incentive to print money and create free money. And so it's not going to go away. People are going to keep trying it, and they're going to keep failing. So in my opinion, I just want to ignore it because I've already spent way too much brain power.
There's infinite numbers of things that need to be ignored.
Yeah.
But there's been floating the argument around from Vitalik that proof of stake offers more security for the same cost.
Bullshit. Another way to look at what is the external resource being used here, right? So in Bitcoin, it's similar to gold mining, and you put in an external resource to create it. What is the external economic resource being put into Ethereum mining? It's interest rate, right? So I'm locking up some coins for a while, and I expect to receive an interest rate on that, right? This is also true in Bitcoin. There is an interest rate aspect there. If I lock up some coins for a while, say because I bought some mining equipment, that is an aspect of every single financial asset, right? But that's not the only thing going on. There is a true utility of Bitcoin mining outside that interest rate aspect, and it is the ability to essentially buy up otherwise unsellable energy to keep solar farms going. And to turn off when we have crisis events like we had in Texas like 3 weeks ago. There is a real utility there. Whereas for just twiddling interest rates, there's another kind of economic instrument where all they do is twiddle interest rates. It's called fiat currency. Proof of stake has more in common with fiat currency than it does with Bitcoin.
Yeah, Bitcoin mining is production. You put capital in, you produce something, and you get your return. And holding on to something, without any production is not, that's true of any commodity, right? There's no inherent growth in any commodity. And And locking up something and not doing anything with it is not production by definition. Right?
It is fiddling with relative interest rates between that asset which you could put your money into versus another one, right? Which is a game every financier plays, and so they understand it, but that's not a way to create consensus because you can't guarantee that your interest rate is going to be better than somebody else's.
Well, interest rate is just the return on production. It's the rate of return on producing things and selling them for a higher price or the same price as all of your expenses put together over, assuming competition. So if there's no production, there's no interest rate. And I mean, that's what interest is. It's the return from producing things.
All right, let's move on before I start throwing things.
Okay. Is sharding a topic that may be relevant to Bitcoin? You often get this kind of question.
Sure, just make it work.
Yeah. I'll say, so I'm a fan of sharding. I am not a fan of how Ethereum is doing sharding. Ethereum is doing sharding as like a chain of chains. You glue a bunch of chains together. So each blockchain has a scaling property it's essentially order n, right? And so if I have n chains that are all order n, right, I haven't fixed the problem. I still have something that scales as order n. There's another kind of sharding called essentially horizontal sharding, where each node can transparently keep a piece of the blockchain. They can tweak how much of it they want to keep, and then collaboratively they all come to consensus about what the chain is. The difficulty there is in proving to other people that you have a particular subset. Let's say we shard along the UTXO set. In other words, I'm going to hold 1% of the UTXO set. You're going to hold another 1%. And then a bunch of people, each holding 1%, can all agree that they have a consistent set. That is an idea that I like a lot more than the way Ethereum is doing it. Because Ethereum's sharding is not transparent. The person writing the transaction has to know which shard they're in, which shard they're talking to. They have to pay fees to cross shard boundaries. It's very complex and very expensive. If you could do it transparently, more the way that RAID hard drives work, right? Or the way that certain error correcting protocols work, and you make it transparent, that would be a much more valuable thing to do. And I think could be something we would see in Bitcoin eventually. I think the project that is closest to this is probably UTXO. Taz Drajja at MIT has been working on this, basically taking the UTXO set and putting a Merkle tree on it so that I can prove subsets of the UTXO set. Now that would be a required technology to create some kind of sharding. And he's talking about it mostly in the context of doing light wallets, where my light wallet doesn't have to know the whole UTXO set, just has to know a piece of it. But sharding is sort of like having a whole lot of light nodes, each of which keeps only a piece, but collaboratively they can all come together and make a decision about the entire UTXO set without any one of them actually having the whole UTXO set. So if you're interested in that concept, I think eventually we might see something like this. I'm a big fan of UTXO. It does use Merkle trees. I would be even happier if instead of using Merkle trees, you used a order 1 cryptographic accumulator, which I don't know that anybody's actually working on, but a UTXO set commitment combined with any form of cryptographic accumulator, which is essentially what the Merkle tree is, can prove subsets and can be used for sharding. And I think that's pretty far off from where we are right now.
I find it all very interesting, but I continue to question the premise that it's important. We have linear growth of the blockchain, right? And we have exponential growth of storage, exponential reduction of storage cost. And Satoshi pointed this out in the beginning. Like this is a race you're not going to lose. So I just don't care that much.
I think that the market has gone a different direction, right? So sharding is along the direction of let's put as many transactions on chain as we possibly can. Now, nobody's really succeeded in doing that in any kind of reasonable manner and getting large number of transactions on chain. Instead, we've gone the direction of the Lightning Network, things like state chains, and taking things off chain. And I think perhaps that is the right answer. I think it's interesting to put as much on chain as you can. I think sharding is interesting, but it hasn't succeeded nearly as well as taking things off chain like Lightning can. And you fundamentally don't have the same scalability limits, right? With Lightning channels, I can pass an arbitrarily large number of transactions. Using sharding or something like that, still has limits. It's just a
You
larger
have other
limit.
material trade-offs, right?
Yeah.
For
That's a
example, I've had people tell me, well, eventually everything will just be on Lightning. And I said, then nothing will be secure, right?
Yeah.
Because if you can't settle, it's not secure.
No, you need to have the underlying chain. Yeah.
It's not just that you can't settle, that you can settle, but you don't. It's that if everybody's just doing Lightning transactions, then everybody can rob everybody else. And the only way they can stop it is to settle. And that settling now incurs a cost. So say you want to do microtransactions, but every time you start, open up a channel, start doing it, somebody robs you and you have to settle and you lose all your, you lose in that one fee, all of your profits for like a year. So you can't, you can't have this without this significant trade-off. So I continue to ask people why other coins aren't just as good, right? Why wouldn't you just use, I don't like to use existing coins because first of all, I don't believe that the fee pressure is high enough yet for this to matter enough. It doesn't matter for microtransactions and smaller things, but another coin has similar but better security trade-offs. Right, you can do atomic swaps between chains. The chains are fully sharded amongst themselves, right? And you can have a lower level of security that's sufficient for the smaller size transactions in another chain. And it can be exactly like Bitcoin. Just give it a, flip the mining algorithm. Now you've got BTC 1, 2, 3, atomic swaps between them, fully sharded, and security appropriate for the level of the transaction. I think it's inevitable, and it's already happening, but people are, I think, in denial about it.
Yeah, I completely agree. The power of atomic swaps is under recognized in this conversation.
Yeah. When I first saw that happening, I'm like, well, this is an elegant solution to all these problems. But there you have people who want to see the price rise in their 1-2 coin. And as a result, they want this. Effectively, that means you want this fee pressure, right? And you can't have both, right?
Yeah. At the end of the day, in the very long term, Lightning and other protocols like it can be characterized as to say, we're going to do some stuff off chain, and we're going to choose not to send those transactions to the chain unless there is a dispute. So in the very long future, the only transactions that will be on chain on Bitcoin will be those that are in dispute, right? It'll be somebody closing their channel adversarially. And that gives you as much an amount of scalability is proportional to the amount of dispute in the system.
But you can't build the whole
financial. We're going to get that by default.
You can't build a whole financial system on that because people just start robbing people and forcing them to settle, right? And you can't settle because your first transaction's worth a penny and your settlement cost is $100. So you let yourself get robbed so that you can do this. Right.
So then you get into aggregation and things like that.
Right. It's but it really only works when the transaction sizes are similar to the fee sizes on the main chain. All right.
Well, amortized, right? If I can perform,
but the proportion of the fee to the transaction size is similar.
Yeah. If I can perform 1,000 off-chain transactions before I hit a dispute, and then once every 1,000 transactions I have a dispute, I amortize that dispute cost, right?
But if I know you're doing that, Bob, right? And I'm just some anonymous hacker out there or whatever, and I want to buy something from you, and I know you're amortizing. You need to get to 10,000 transactions before you can break even. I'm just going to rob you, right?
And force you to close on chain, yeah.
Yeah, but you're not going to close out because you're going to lose a ton of money. Right, so I know you're not going to close out.
Why wouldn't you close out?
Because you're going to have to pay the fee to close out, and the fee might be the fee's $100, and I just did a penny transaction. You're not going to close me out to save that penny, right? You're not going to, and everybody's going to know that. So when the disproportion is high enough, people are just going to rob each other blind, and there's nothing anybody's going to be able to do about it.
And that's an interesting argument. I haven't encountered this before. Has anybody written a blog or something that points this out?
This is one that I've been meaning to write up for a long time, but I hesitate to write about Lightning because I haven't coded it. And I really like to only write about the tech that I've coded. I don't like to make technical errors. But from an economic standpoint, this is the issue with Lightning. is that you have to open and close to do these transactions, which you have to aggregate. And the risk that you're taking is that somebody doesn't just rob you and it's too expensive to close or have opened in the first place. And why wouldn't they do it? Right? Why wouldn't they just say, I'll take that free Coke, why not? That guy's not going to close out. So well, it works when the transactions that you're transacting on Lightning have a similar value to fee ratio as the ones on the main chain. Now you will close because, well, worth it.
I think we should postpone this conversation because I'm not really prepared to do this, but I don't think it works because the way an adversarial actor does that is that they close out on chain using an old state of the channel. And so then they are paying the fee, right? So the attacker is paying the fee. And then you, as the person being stolen from, where they're broadcasting an old state, you have to pay that fee instead. And this comes down to who pays the fees on channel opens and channel closes, but I'm not sure that works.
Yeah, well, again, it's one of the reasons I haven't written it up. I have to code this stuff to make sure that I'm not, not making errors. But the more important point to me is that I don't really see it as necessary to make these trade-offs. You can do smaller transactions. It's just a question of technology and implementation. You clearly can do smaller transactions on smaller chains today, and you clearly can do atomic swaps between chains, and those chains are clearly sharded. If you don't care about the smaller chains or the bigger chains, you don't need them. Mm-hmm. And so why wouldn't you do that? Well, smaller chains are shitcoins. No, they have the level of security appropriate for that level of transaction. If you're doing penny transactions, right, and the block reward that somebody's going to get by robbing you is a few bucks. Why are they going to spend, say, $1,000 to do it? And it's the same argument for big transactions on Bitcoin or BTC. It's financially rational, and it solves these problems.
In practice, though, I don't see a lot of people doing that. And in fact, I don't think a lot of people have. I mean, because people want their assets denominated in the same thing. So if you could figure out a way to do all of that while having the denomination remain the same and not incur like a new interest rate or
that's entirely superficial, right? We use dollars. We use dollars, pennies, nickels, dimes, and quarters, 20s, 50s, 100s, 5s, 10s, right?
Well, yeah, but the value of a dime is always 1/10 of a dollar. It's fixed to 1/10 of a dollar, right? The value of a Litecoin is not fixed to the value.
The value of a 50-cent piece from a few years ago is not the same as a half a dollar, right? Those vary, and that's why some get hoarded, some get saved, right? There are differences, and these differences that we're talking about between chains they're technological, right? You could write software that papers over all these
hide all of it
and do atomic swaps between them, and nobody would even know it was happening underneath, right? I'll point out here the Strike and Zap project by Jack Mallers, which essentially does this with fiat currency. They are using fiat currency. They're sending fiat currency via Bitcoin. So you're in their app. You can send dollars. And on the back end, they're actually sending Bitcoin and using the bearer instrument back end of Bitcoin, while at the same time essentially doing arbitrage to make it a fixed dollar value, right? So as you're talking about like papering over all this complexity. Yeah, you can. This is an example of doing so. Yeah, to me, it's actually one of the things I find interesting from a much longer term standpoint. I mean, it doesn't happen until there's sufficient demand. That's why these altcoins don't really get too far, is because there's a network effect in Bitcoin. The fees have been relatively low for the types of transactions people want to do, except during these big price spikes, maybe. But in order for an alternative to grow, there has to be sufficient demand. And when that demand happens, say it was $100 or $1,000 to get a transaction confirmed on BTC. Yeah, then there's sufficient demand to go out and have another chain that has, a much smaller fee. Do your transactions, your smaller transactions there, and then secure your larger amounts for a higher fee. This is what people do with, their fiat money or their commodity money throughout history, right? You have a cold vault somewhere, and it takes you time and money to get money in and out of that. And then you have your leather wallet in your back pocket, which if you get robbed, it's not as big of a deal. You switch between them at a cost.
It's an interesting argument.
Lightning is doing too, right? You're reducing your level of security in some aspects so that you can transact more cheaply, and you're paying to get things on and off the chain to secure them more highly. This is just a different way to do it. But it seems to me a pretty straightforward way to do it that could be covered by technology.
Yep.
I just texted out a link to what I call the fragmentation principle, which is kind of a quick discussion on that topic. Somebody's asking about I guess USDT and I think that's a shitcoin. I don't know much about it.
Okay, yeah. Eric mentioned already pooling pressure and the proximity premium flaw that is inherent to how Bitcoin mining works or how the Bitcoin mining ecosystem works. Do you have something to add about that? Yeah, still, Eric, because that's definitely something that Bob and, as I today learned, you two tried to solve in the past.
Yeah, I Bob was doing the most interesting work on this. I was really excited when I saw his presentation on braids in Hong Kong, and I grabbed him right away. I mean, he keeps up on it probably more than I do. So I'd love to hear from him what the latest is. What's the state of the art here, Bob?
Sure. Well, okay. So this goes back to 2015. This is a kind of passion project of mine. I approach this as I think many people have, like, well, okay, Bitcoin's not perfect. How can I make it better? This turned out to be a bad idea, but this is where it led. The problem is, without actually giving these talks again, you can go watch these talks or see the slides. There is a coming pressure on Bitcoin coming from the pools, right? We currently have pools that are about 20% of the hash rate each. And the reason that they are that big is because people are trying to reduce variance. That's the purpose of a pool. And this is a big risk. It's a censorship risk. It is a government control risk. They're an easy point of attack. In the next phase of Bitcoin, where we go from, currently today we have big institutions starting to invest. The next phase of Bitcoin is going to be governments getting involved, and they're not all going to be friendly with this. We need a decentralized mining pool. And, when I first started this work, I thought, well, maybe we could get this into Bitcoin itself. I now think that's probably a bad idea. But it is almost perfect for creating a decentralized mining pool. There used to be a decentralized mining pool called P2 Pool, which kind of died. And it died on the back of latency problems. So they decreased the block time down to about 30 seconds, and the orphan rate went up correspondingly. And the benefit you could get by having low latency to other miners in P2 Pool grew. And so people gamed that system over the topic of latency. And so I did some work a couple years ago now looking at what is the structure of a directed acyclic graph necessary to essentially reproduce the properties of Bitcoin, except having a graph. In other words, each block can point to more than one parent. And I call this a braid for a technical reason. Each block can point to more than one parent, but it cannot point to any of its own other ancestors because it's not necessary. It's there by implication. Some other graph-based chains out there got this wrong, and in my opinion, it's an indication they had no idea what they were doing. IOTA in particular, IOTA does point to its own grandparents as ancestors, which is just unnecessary and a waste of data. But anyway, so you can create a DAG here. You can run it the analysis that I did specifically found that you could run that graph about 1,000 times faster than you can run Bitcoin. And the limitation there is latency of transmitting signals around the Earth. It's related to the size of the Earth. Anyway, so where is this today? I would like to see this made into a decentralized mining pool. I want to reboot P2 Pool. I personally have not had enough time to put into this in recent years, and I would love to see other people doing it. I know Eric's interested. There's another fellow here I've been talking to a lot, Jungly, in the chat. wants to create a prototype implementation, I want to encourage all of you. I put out there everything I could think of about it. There's some simulation code to simulate a DAG. And I think this is, in order to survive the next phase of attacks on Bitcoin, which are going to come from governments, and they're going to go for the pools first because they're the easiest thing to attack. They first go for the on-ramps, and then they're going to go for the pools. If we have this, if we build this before those days come, we may be able to save ourselves from governments actually taking down Bitcoin.
So why is this better than Stratum V2? Or
Stratum V2 helps. It's a step in the right direction. I am not the right person to talk about Stratum V2. I haven't looked at it in quite some time because nobody was using it. And I think more people are using it now. But if other people have something to say about Stratum, I'd love to hear from somebody else who knows more than me. It's not the same approach, though. Stratum has lots of problems that are really unrelated to this.
Yeah, there's been a couple attempts to deal with this problem in terms of just trying to speed things up or refactor, payouts, and they don't work for reasons I pointed out right when they came out, and I got a lot of resistance from people who work together, but they're pretty obvious. And when Bob and I were talking about different solution to this, we can discard these things pretty quickly, but they tend to catch on, and they get it. The problem is they get people's attention. They think these problems are solved. For example, the two examples that I wrote up, I called it decoupled mining, right? Decoupling the payout from the transaction selection, which is the obvious problem of, the person who controls the payout is still in control. Right? Yeah. And okay, I mean, there was a whole, I'll put that one out right there in the text, is decoupled mining. The other one was just improving relay speed, right? Well, yep. If there's an
That's happened.
Yeah, sure. If there's an improvement to relay speed, what it means is that your miners are more aggregated, right? It's not a disaggregation of miners. It means they're time-wise closer together. And the way you achieve this, you can achieve this by improving the implementation of networking protocol in Bitcoin, right?
Yeah.
There's no consensus issue there. You just change it, come up with a new one, and make a better implementation. So that's one thing. You can speed up the network transfer, and that's been done external to like the node that most people run, and it's fine. There's another approach, which is SPI mining. You just, it's similar. You just connect your mines, as a competitor to your competitor's mines directly, and you get the information as soon as any of their rigs get it. That's probably the most effective and probably what's done the most. I think, people I've talked to that mine tell me that. But there's another way to do it, which is it's kind of. I wrote this up as a relay fallacy, right? The relay that came, I forget what it was called, Fiber, right?
Yeah, Fiber and Falcon are the two big ones.
Right. Why wouldn't you just put it into Bitcoin Core and LibBitcoin and everything like that? Why just make it all
why not? Why not?
I know why not, because there's two implementations of it. One of it requires centralization, and one of it doesn't. So
in practice, what has happened is that we don't need it, right? So there are a couple of improvements that have happened, since I gave these talks in 2015. Relays being the big one. So at the time I gave that talk in 2015, if you watch that talk, I gave an estimate of the latency that it took for a block to reach 50% of miners, and at the time it was about 6 seconds for a block to reach 50% of miners. And at the time, 6 seconds over 606 seconds, which is a block time, is around 1%. I think this is related. I think Satoshi did this calculation too. And I think that's why he came up with 10 minutes as the block time, because he wanted, and that's really a function of the gossip network and random interconnections in that network, right? So draw a graph on the surface of the sphere of the nodes, interconnect them randomly, let them use gossip, which is, everybody resends every message to all their connected peers. That system, for the size of the Earth, has a mean time to reach all nodes of about 6 seconds. Relay nodes got inserted to that were essentially fast point-to-point links that transmitted blocks very fast. They had a side effect that it only takes a couple of these around the Earth to improve everyone's latency. Even if you're only talking on the gossip network, chances are good you're within 1 or 2 hops of another relay node. So only a handful of people using these relay nodes drastically brought down the latency. Right. So today we're talking about, you know, only a couple of orphans a year. The number of orphans went down drastically.
We need to look at the bigger picture, right? First of all, how is anything improved by reducing the number of orphans, right? Well, miner profitability goes down, but that's all compensated for by the fact that it's a zero-sum game, right? There's a net no change. Okay, everybody gets faster. Okay, there's fewer orphans. Miners are still making the same amount of money they make, right? Yep. And but the effective relay. So this, again, I mentioned 2 types of this relay. One is it's essentially peer-to-peer, not necessarily a broad gossip network, right? But it's anonymous, right? But then there's an aspect of, I'm specifically referring to Fiber. I've sent out a link on this, the relay fallacy. Fiber's speed, the real benefit to the real performance benefit to Fiber is that if you join a private network, you don't have to do the same data confirmation. You know, people, in other words, the network doesn't do the validation checks. It can't on the data that's being sent, and that's how it gets a performance improvement. And by not doing those validation checks, you have to secure the network against bad actors. You have to be able to exclude them. So it's inherently not decentralized. Somebody has to operate it and kick out bad actors. And as a result, what you've done is created another pool. You've created somebody in charge of collecting everybody's mining data, and that person's in charge. They can block people. They can filter out transactions. They can force people to signal. They can charge for it. And what was really ironic is that when the satellites went up, one of the ways they said they were going to monetize it was charging for a fiber relay. I'm like, yeah, of course, right? That's what it is a centralized system. You can charge for it. So it doesn't change the security model by introducing another aggregate miner. And speeding things up generally for everybody doesn't change anybody's profitability or the security model. So if somebody does it, everybody else has to do it. That's the zero-sum nature of it. But okay, just put it into the P2P protocol then, right? Or
yeah. So MZ is pointing out in the chat that the public fiber network is offline and compact block relay has replaced it, and that's as good as having the fiber network.
Right. So we put it into the P2P protocol and got rid of the centralized system, which is great. You know, right. and
so there's a remaining problem though.
You could make it faster by centralizing it, right? Having one miner collect all the data from everybody, but how does that benefit anybody? It's centralizing and it's still the same profitability. So what we want to do, what you want to do, and I want to do is let people mine as independent people and be as profitable as somebody who's mining as an aggregate. It's the profitability that matters. And so we get into the Stratum V2 stuff, and there was this theory, again, very naive, that you could let the people who are doing the grinding, I call it, or the hashing, select the transactions and share their payout. But the person who's making the payout still has control. They can still censor. So you're
paying yourself. So the way, you're completely right. The person. So Stratum V2 allows you to do your own transaction selection. So it's a step in the right direction, but it doesn't really solve the underlying problem, in that you might not get paid, right?
It's about profitability. That's the problem.
If you don't censor in the way that your pool asks you to censor,
they just don't pay you.
They just won't pay you. Yeah. And so this doesn't actually solve the problem. The difference with like P2 pool or hypothetically Braid pool would be that you're paying yourself because you're actually mining a block, and that block contains your own payout for yourself, right?
The problem is now variance and latency. And you did a good job of explaining to me the P2 pool significant latency issue that I can't remember the details of, but
I can give that again, sort of.
I'd love to hear that.
So P2 pool, what you want to do. So pools operate off of shares, right? A share is what you might call a weak block. In other words, it's a full Bitcoin block, or at least the header thereof, that doesn't meet Bitcoin's proof of work target, but instead meets some lower target, right? Yep. And a pool collects these shares. So miners submit many of these. the pool keeps those, counts them, puts them in a database, and say, well, you submitted 500 shares in this time period, and therefore you're due 500 over the total number of shares in that time period of a block reward, right? Now, this is all centralized, of course, right? The pool is keeping this in a database. They could get the records wrong. They could refuse to pay you. They could get co-opted by the government. They could get attacked. They could get a subpoena, all kinds of stuff, right? What P2Pool did is it created a rule that said, here are the rules of a P2Pool block. In particular, a P2Pool block has to pay other miners, right? So they decrease the block time to 30 seconds. And by doing so, you have 20 times more blocks in the P2Pool node, right? So on average, one of those 20 blocks will be an actual Bitcoin block. Again, they're all weak blocks. It's merged mined with Bitcoin. And on average, one of those will be a block. And that block has to pay all the other 20 people, right, who are mining. And that was kind of the point. That's the way it worked. And that's the goal, where the miners pay not only themselves, but the other people who contributed shares. And you can set up a set of decentralized rules around collection of those shares, accounting of those shares, proof of those shares. Those shares are themselves proofs, right? They are block headers. They have a proof of work in them. And so I can construct a completely proof of work blockchain out of this. The problem that P2Pool had was that if you lower the block time to 30 seconds, your orphan rate goes up like crazy. At the time that this was running, the 6-second measure was in effect. So 6 seconds over 30 seconds is one fifth. So you have 1/5 of all, 20% of all blocks got orphaned, and they called this quote unquote dead on arrival. And they tried to play some games with trying to fix this up, but never actually fixed it up. And I know personally some miners who very much screwed around with latency and tried to connect to low latency other miners, right? And were able to drastically increase their profits by doing so. And this is the entire point of putting in a directed acyclic graph, is it can completely solve that problem so that you're not competing on latency. And that allows you to bring the block time down, and it allows you to collect more shares, right? So 20 times more shares than Bitcoin is not really enough to reduce your variance enough, your payout variance enough to really make it worth it. With a braid, you can get to about a factor of 1,000. 1,000 times faster blocks brings your it brings down the variance on your payout substantially. And there's some more details on this in the talk I gave at the Magical Crypto Conference in 2019 about the variance arguments.
Remind me again the central issue that we ran into with braids, or that you ran into, I think, before we had these conversations.
The central issue I ran into is I didn't have enough time, and I needed help. What are you referring to, Eric?
No, I mean, we ran into, I remember we talked about, I think it was early Lightning, and we're talking about bringing payouts onto Lightning. You were running into a problem which was inherent, not just implementation.
I think I've solved it. I think you ran into a problem that I disagreed with you on, this is about incentives, if I recall correctly, right?
Yeah, it was just an IRC chat, I think, and I don't have the logs. I would love to rehash that.
At the end of the day, I made a certain contributions. I did not make all the contributions. I didn't write a spec, right? I would love to see this done, and I want to encourage everybody listening who might be interested to help carry this forward. My time is sufficiently constrained that I'm probably not going to be able. I'm not going to be able to write this all by myself. I will, again, brain dump what I've already done, and I hope it's useful.
Jungly will write it for you in Bitcoin.
Awesome. Yeah, I talked to him a lot. So get in touch with Jungly on Twitter for those that are interested.
I have a question here, guys. I remember bringing this up with you, Eric, on Slack, right? And you were saying the problem is the latency between the large miners and the miners working on the P2P pool. And I really didn't fully follow.
Oh, yeah.
So do you remember something?
Back in the day, Eric and I, you and I were talking about what happens when we have a network where some of the miners are mining on the decentralized pool, and some of them are mining on centralized pool. And how does the decentralized pool not get screwed over by the centralized pools? I think is that's what we were discussing at the time, right?
Yeah, if you have a PETA pool that's say 20%, and you have large miners that are 30, 40, 50% ish, right? They have, between the two pools, you have a disparity that's going to always make the larger groups more profitable. Even if you set aside any of the issues that are caused by the PETA pool, right? Introduction of higher latency, or higher fee transactions to settle because you're paying multiple people, which sounds like an issue also.
Well, so that was another problem with PETA pool. So again, this is not a solved problem, and this is not for all the people listening, this is not a complete proposal. Okay, this is a set of ideas that I would love to see discussed more widely, and I think there's a lot of work to be done to bring it to fruition. Eric just brought up another problem with P2 pool, and that was that its Coinbase was essentially competing with other transactions. In other words, because a P2 pool Coinbase on average had to pay out 20 other miners, and in practice, because they also averaged over multiple successive blocks, ended up paying hundreds of other miners, you can only fit around 2,000 transactions in a Bitcoin block. And so these P2 pool Coinbases were ginormous. They were paying hundreds of other people, and that was directly competing against the fees that could have been earned at the time. So you don't want that. And so for this, I think the solution to this is to not actually use the Bitcoin Coinbase in that way. Don't put the payouts for everybody. And if you run the blockchain 1,000 times faster, that's 1,000 payouts you got to do on average. We definitely can't afford that, right? So how do you solve that? One answer, and this is the one I gave in this Magical Crypto talk, was have all the rewards occur on the braided chain, on the share chain, right? And you get paid in a different coin. It's a share coin, right? And then what you do is you do atomic swaps between that share coin and Bitcoin, unless you're one of the lucky ones that actually got real Bitcoin. In order to do that, you have to pay an amount of share coins in order to receive the Bitcoin, right? So what you do is you create essentially a market around Bitcoin and share coins, so that you don't have to put all of the payouts in the Coinbase. There are payouts in the Coinbase of the share chain, but not in the Coinbase of Bitcoin. And instead, you use things like Lightning and atomic swaps to go between the share coin payouts and Bitcoin payouts. The details of that require working out. I haven't given you a complete specification. I'm sure you can see problems with it off the top of your head, but that's one potential route. Another potential route is one that I discuss a lot with Chris Belcher. He had this idea of using essentially a hub and spoke channel model, where the idea is that the Coinbase on Bitcoin is essentially an opening of a multi-sig Lightning channel that pays everybody. I'm not particularly a fan of this. He put a lot of work into it. It's worth reading what he wrote to see if that could be an option, right? Taking these small payouts to small hashers off chain and putting on something like Lightning, in general, be a good idea, but the devil's in the details.
Okay, just very interesting to follow up all that. Just wanted to point out there is an article from by Eric about the selfish mining fallacy. Maybe you can go into that a little bit, if this is more a discussion about terminology or.
Yeah.
One I think is really about terminology.
I agree. My point on it was it's kind of a moot point, right? I think Bob and I have both written on this. Selfish mining is interesting. I actually tried to prove the math to myself, but I'm not much of a math guy, so I gave it to somebody else who is, and he didn't see any problems with it. So I'll just accept the math at face value and the assumptions of it. But then you get into the so what of it, right? Like what it implies is that there's pressure for miners to work together, right? That there's pooling pressure. Yeah, there's inherent pooling pressure in Bitcoin, and the pooling pressure, all results from the same things. The selfish mining. I mean, all miners are selfish. First of all, I refer in the book I refer to. I use the term selfish mining to just somebody who doesn't build on somebody else's blocks. Right? I'm selfish. I'm going to build on my own blocks. And if you're the 50 If you're the majority miner, you don't have to build on anybody else's blocks. The selfish mining topic basically dealt with what are the issues if you're less than the 50% miner. Is it still beneficial to only build on your blocks, or build more than one block and then announce it? Well,
so the basic argument
to me is like, so what? Right?
So the basic argument of the selfish mining paper is that there is a strategy for mining where you try and mine 2 blocks at once rather than only 1 block. And if everybody follows that strategy, the 51% attack risk is actually a 33% attack risk. You can earn more coins, and one might call it unfair to do so. Now, the reason that works is because different blocks have different payouts. Specifically, a block that becomes part of the main chain has, gets a block reward. One that does not become part of the main chain gets 0 reward. And it's that disparity in rewards between an orphan and a main chain block that causes the selfish mining problem. That's what causes this game to exist. This is one of the things I wanted to solve by using a directed acyclic graph. Essentially, in one of my talks, I called it equal pay for equal proof of work. In other words, if I submit a proof of work, why shouldn't I get the same payout as somebody else who submitted proof of work, right? And that can be achieved using a directed acyclic graph. And it's achieved by removing the disparity between 2 different blocks who receive 2 different rewards. Make them have both the same reward, and you solve the problem.
Good. Any questions or remarks from anybody else?
Yeah, probably one question on a related note. I wanted to get your opinion on Bitcoin's long-term security model, and I've been getting this question a lot from people that have come to understand Bitcoin a lot better, and fortunately the Ethereum community too. And they now think, people from the Ethereum community now think that Ethereum is more sustainable in the long run, thanks to like proof of stake security model compared to proof of work, given that block subsidy is running out. Like, I guess specifically down the road, say after 4 or 5 more halvings, or let's make it 10, we're down to a fraction of Bitcoin in the block subsidy. So there's this paper by the Princeton people called, I think, on the instability of the Bitcoin block reward or something like that. Actually, I think it's on the instability of the Bitcoin without the block reward, I think. And anyway, what they show is that in the long run, like 40 years down the road or so, relying on transactions only might not be sufficient.
So let me describe that. So first of all, the paper you're referring to, the Princeton one, it's on the instability of Bitcoin without a block reward. And so I've read the paper. I think it's correct. And their argument is essentially that if there was 0 block reward, right, and all of my fees came from transaction fees. If I'm a miner, right, and somebody just mined a block, right, they just mined a block, and when they do so, they essentially extract all of the most valuable fee transactions from the mempool. And I am, by definition, going to make less money by mining a subsequent block, because whatever's left of the mempool has less fees than the block that was just mined. My incentive at that point is not to mine a new block. My profit-driven incentive is to remine the block that just got mined in the hopes that I could orphan that block that I just saw and try and take its transactions, right? And now this is a situation that results in nobody actually extending the longest chain. The solution to this, or one way to solve this, that was discussed by David Vorik a bit when he gave a talk about something he called Jute at the MIT Bitcoin Expo, which is closely related to what I was talking about with braids. And he brought up the concept that if you have what he called a deep mempool, in other words, there's lots and lots of transactions in the mempool, such that when a block gets mined, there is enough profit in the remaining mempool for this second miner to go ahead and mine an actual block. You can still go ahead and extend the chain. That I think is where we're going to end up in terms of long-term security. the notion of not having a block reward after several halvings, as was mentioned, but also not having any transactions that pay fees, I don't think is realistic. You know, we're already in a quote unquote deep mempool situation. There's lots and lots of transactions in the mempool.
If you don't have, I mean, you don't have fees, you don't have censorship resistance, right? It's the source of censorship resistance. So what's the point? Right. You could make a Bitcoin like thing, a shitcoin that has only an inflation reward, and you know, people sometimes ask, well, why didn't Satoshi do that? I don't think Satoshi. I mean, Satoshi clearly he said that, you know, a random lottery is as good a way as any to get the coins out there. So why not piggyback on this mining thing, right? That was a technique to get the coins out, and he said, well, why not phase it out? You know, we only need a certain amount of coins out there. We don't need, you know, perpetual inflation. The mining of those coins is at cost, so it's not seigniorage. It's not a price inflation issue, which most people believe it is. But the point is, you know, once you've reached a certain point, you don't need to mine anymore. So, but the interesting thing is that the side effect, you know, what he probably considered a side effect was actually the central effect of a rational model for fending off a censor, right? An inflation-only coin has no censorship resistance because the censor earns the same as the non-censor miner. So why wouldn't everybody just go along? You know, there's no reason not to. But if a censor is not taking, if you're a fee-based coin, if you're a Bitcoin, right, and you know, just ignore the inflation reward, it's gone someday. If the censor is not mining, you know, some large number of transactions and the fees are rising on those transactions because they're not mining them, that's opportunity for other miners to come in and make a premium for mining those transactions, which they presumably are doing at a higher risk. So they need that premium. And it's worth it to the people who want to get them through because they're censored and there's a reason they're censored, right? So there's a very rational, elegant solution to censorship resistance, which I don't think Satoshi even recognized. He never mentioned it. I could never find anybody that mentioned it. It took me a year, you know, noodling on it to figure out where this money comes from, and then it was obvious, right? So to me, it's kind of a moot point. It's necessary. The reward has to be, you know, coming from, and it's not necessary that the reward. It's not necessary that the fees are paid in the transactions. That's another thing. It's a nice side effect. It's what provides anonymity, right? I provide my transaction to, you know, the whole world of miners, and I don't have to tell them who I am. As long as they don't know who the transactor is, they don't know who's paying the fee. But I could go to a miner, pay him a side fee, and say, mine this transaction. I go to all miners and say, hey, I set up a side fee system and whatever. It doesn't matter. It doesn't change the economics of anything. It just removes your anonymity. So, you know, Satoshi came up with this, you know, elegant way to pay fees, which are necessary for censorship resistance, and provided, you know, anonymity that's sufficient as the transaction anonymity to do so. Great, but it doesn't work if nobody's transacting, right? Yeah. That's the source of the security, is the fact that people are using the money. That's true of any money. So basically, the presumption, like you said, you know, you have a valuable block, it's mined, and there's no other transaction, so people attack that valuable block. Well, at that point, why shouldn't they? There's no problem with that. Just keep mining on that same block, and those same transactions are just going to circle around for a while until some more valuable transactions come in, and now we can start building a second block. So yeah, you want confirmation depth. It's not a problem. It's just people have to want to excuse me. They have to want to transact in the money. They have to need the money for some purpose. If everybody just hodls their Bitcoin's worthless, as is any other thing that people don't trade. You know, value is what you can trade for something.
So to directly answer the question, we have to transition to a fee-only blockchain at some point for the purpose of censorship resistance, right?
To raise,
in which case,
there is a level of it now, but it has presumably, if it's on 100% fee-based, it's as censorship resistant as it can get. If you have
in which case the Princeton analysis applies to it, right? But you can only transition to a censorship resistant coin that pays for things with transaction fees when you have lots of transactions. And so these two have already happened in concert and will continue to happen. So in practice, I think this is not going to be an issue, because only if the transaction volume drops to zero does this paper become a problem?
Right. If people don't want to use the money, it's not going to be secure. Period. Right.
Yeah.
And
You're bribing miners by paying fees to include your transaction.
Right? I mean, I look at it.
You're paying them. Yeah.
I look like the Visa network. First of all, people see people who are spending as paying the fee. That's just a technology thing, right? When I go to the gas station and I use a credit card, am I paying the fee or is the gas station? We're both paying the fee, right? And I don't care if the transaction to Visa gets confirmed. I don't want it to get confirmed. So it's not in my interest. I'm not paying Visa to confirm it. The merchant, that's why I use the term merchant, validates my transaction. I don't validate it. I don't care. I wish it was invalid and he took it, right? He validates my transaction and he pays the miner a fee so he can get paid, right? And it's the way we look at it is like, when people use those terms like bribe or they need a better real world analogy to what's actually happening, and that's what's happening. I'm giving a merchant some money. It could be good, it could be bad. I don't care about the fee. The merchant wants to make sure it's good. He validates, and the merchant wants to make sure he gets paid, so he pays a fee. And it should really be from a user interface standpoint designed so that the merchant gives you a bill. There was there's a bib for payment requests that kind of handle this, but not in a very good way. But merchant gives you a bill. They put the fee on the bill, and they have the ability to bump the fee, and ideally, and they give you confirmation that you paid, and then they go and buy a confirmation from miners. They're just buying it, and if it's more valuable for them to get it confirmed, they'll pay more. But if people aren't transacting, they're just hodling their coin. Their validation doesn't matter, and they don't provide anything to censorship resist the coin. And if everybody does it, the coin's worthless. So transactions matter a lot in Bitcoin, and there needs to be an economy, which I define as the set of all people who accept the coin. If there's no economy, there's so I like to work on things also that increase the ability to people use the money, the things that the money is used, time, the things that are permitted. There's other money for all the permitted things, right?
Okay, somebody has any remarks or questions? No, then let's move on. 2-0 knowledge proofs or 2-0 knowledge technology. Bob already mentioned that this is an interesting field.
I don't have a heck of a lot to say about this. I'll make one comment. This is brand new stuff, and it's, as with any new technology, is always a risk. My favorite paper out there is called the dark paper. So people have started using polynomial commitments and class groups and groups of unknown order in creating zero knowledge proofs. They are small, they are fast, they don't have a trusted setup, and this is absolute black magic. Snarks are kind of old school tech. I mean, it's used in Zcash. They have a trusted setup. And in many ways, I think Zcash kind of jumped the gun by creating Zcash when they did, because it was pretty clear, even at the time Zcash was being created, that there were better things on the horizon from zero knowledge proofs. If you were to create Zcash today using, the dark form of zero knowledge proofs, it would be very different. And that team, by the way, the Zcash team has incorporated a lot of those things. Anyway, yeah, I'm super bullish on the use of ZKPs, but it's super, super technical, difficult stuff that you have to have a PhD in cryptography to use. How it's going to affect the rest of us, time will tell.
This is the other aspect. I mentioned there's like, what does core development work on, right? To me, the important things are resolving pooling pressure and improving privacy. And this is important work. All the work being done in core Bitcoin development to improve privacy and zero knowledge. It's exciting stuff. I also believe it has a lot of lot of potential. Yeah, there's an interesting kind of funny thread going on in Bitcoin Dev. Bob, have you seen this?
Which one?
There's a guy, I don't know who he is, but he has some royal title from some English place, and it just seems completely like trolling, but people have been kind of going along with it, at least devs, myself included, because it's an interesting education, and basically he seems to run some coin analysis group and really is anti-Taproot because it improves privacy, and you can imagine the response that gets from the Bitcoin dev community. But it's been a really interesting way for people to explain these things to other people. And
I haven't been following that thread. Lord His Excellency James HRMH.
Yeah. If somebody wants a good explanation of all these things, the responses to him are just pretty good, and they're a little bit tongue-in-cheek, but some of them are very serious and lengthy. And I think that's why he hasn't been booted off the mailing list. There's a good archive for Bitcoin-Dev emailing list that if you wants to read those topics about these aspects of privacy, it's pretty good.
I do think privacy is terribly important. I don't think Taproot gets us very far. It's a very small improvement. Things like mixers and coin swaps and zero knowledge proofs, we're not going to have to put zero knowledge proofs into Bitcoin. We can use them outside Bitcoin. In some ways, various kinds of proofs are used in various kinds of ways in any kind of off-chain protocol. And that's where they're going to get used. We're not going to put these into Bitcoin. I don't think it makes sense. Maybe in the very long term, the ability to verify a zero knowledge proof could be very important, but you pay for that in terms of on-chain load. And even the best zero knowledge proofs consume a tremendous amount of data compared to Bitcoin transactions. They're very large.
Do you remember Andrew's presentation at Milan? Scaling?
Yes. Andrew, which Andrew? Andrew Miller?
No, Polstra? Yeah. Andrew's first name, right? Pretty sure. Yeah. What was it was a zero knowledge proof. It was a kind of a theoretical proposal for a blockchain that somebody had just posted anonymously and used a name from Harry Potter. What was it?
Mimblewimble.
Mimblewimble, yeah. Mimblewimble.
Yeah, that was a long time ago. I mean, Mimblewimble has now been implemented in the Grin as well as, what's the other one? The Grin coin is a Mimblewimble coin. It doesn't use zero knowledge proofs. It just reverses the order of some of the things it's proving. It's very clever, in my opinion.
Yeah, I thought it was very interesting.
It allows aggregation. A lot of these zero knowledge proofs also allow aggregation. The question is, can I take two zero knowledge proofs and add them together and make a zero knowledge proof that proves both of them in a space that is constant, so it doesn't increase in size as I add more things. And several of these new proposals do have this aggregability property, which is very, very interesting. I could prove the contents of an entire block in one compact statement without having to run an entire full node.
So,
that can be used in lots of interesting ways.
Zero knowledge accumulator?
Yeah. The problem is that a lot of the primitives in Bitcoin, and specifically the SHA hash function, are not easily implementable in a zero knowledge proof. So commitments become more difficult. Zcash uses internally some other kinds of commitments called a Patterson hash is what it's called, which is more friendly to the primitives used in elliptic curves. The primitives used in zero knowledge proofs, but allows you to make a commitment similar to a hash. Anyway, this is all stuff that, in my opinion, is still at the level of academic research. This dark paper, just like 2 days ago on March 17th, a flaw was found in the original dark paper and an update posted with it that fixes it. So, this is fast moving, and one should always be cautious when importing things that come from academia the day after it comes out from academia. The usual prescription is wait a little while and see if anybody breaks it first.
Yeah. Or if it hasn't been broken from the start.
Yeah.
I mean, inside job.
It's hard to do. It's all
Okay.
math.
It gets tried a lot, right?
Not with zero knowledge proofs, not in the academic literature.
You don't think the spooks are planting people in higher academia crypto spaces?
Well, they have in the past. Yeah, I mean, there's the DRGB infamous example, but I don't really think they're doing it much anymore. Everybody in academic circles is wise to that.
Yeah.
And so the spooks are not easily inserting things into these protocols.
And when you get to that level, it's a small group of people that could even do it.
Yeah, that's right.
Okay. There are also a few articles still that I wanted to go into by Eric, because Bitcoiners like to argue about with network effects and also with jurisdictional arbitrage. That in the process of hyper-Bitcoinization, you'll have more and more central banks being forced to adopt Bitcoin, and then one domino stone will fall after the other. But Eric disagrees with these. Maybe we can go into this a little bit.
Well, maybe it's not necessarily what you said that I disagree with. Anybody can decide that they want to accept Bitcoin, including central banks. The question is whether it's a benefit to anybody. If there was one person who entered the Bitcoin community by writing a book about this, and early on was tweeting a lot about it before the book came out, and then asked me to review the book. And the idea was that we have this massive financial system, and ultimately what's going to happen is central banks are all going to use Bitcoin as a reserve, and the existing financial system will just operate on top of Bitcoin, and therefore there won't be any inflation, whatever. I said, that's stupid, right? Because, and that's why when I ended up writing the blockchain fallacy. But unfortunately, the book had already been mostly done, and so it went out, and a lot of people adhered to this idea. And I think as a result of my critiques, kind of backed off what was very clear initially, which central banks using your existing credit cards and checks and whatever, just operating on top of Bitcoin as a reserve. Well, imagine if all the central banks in the world are the ones that hold the Bitcoin and everybody else just uses this system. Who's validating transactions? They are. Who has the economic supermajority? They do, right? Who wants inflation? They do, right? So they just change it, right? You have no power whatsoever. And there's two things that the state wants from any money, which is why state money exists. They want to be able to create some for themselves at below production cost, which is the source of signage. It's a tax on the people who hold the money. And they want to be able to tax you in other ways, which means they want to be able to see everything you're doing financially, which is they want transparency. Transparency is achieved through censorship in Bitcoin. If you have majority hash power, you can censor. Inflation, is enforced by, so that's enforced by the mining community, and inflation started against, signage is started against by the economy. The people who accept it, not people who hold it, because people accept, validate, and reject and validate money. So if the acceptor of the money, of the Bitcoin, is the state, it's pointless, right? And if you build a whole financial system around this, and it's not a bunch of people independently validating the money and rejecting that money, it's completely, again, it's pointless. So the fact of central banks coming on board and saying they want to hold some Bitcoin, to me, it's not anymore. It's not that important, right? Large companies, white market companies coming on and doing the same thing. Yeah, it's going to create price increase, but what does it do for Bitcoin? Right? All of these large companies, and including central banks, will do whatever the state tells them to do, or they won't be white market anymore. They'll be black market. They'll be operating illegally. They are not permissionless. Business is highly decentralized around the world. There are millions of businesses, and all white market businesses pay tax because they're told to by the state. Being decentralized is not enough. You have to hide. You have to be willing to do it when it's not allowed or it's not permissionless, right? Central banks, big, white market stuff built up over the system, it doesn't add to the security model. So to me, it's kind of very counterproductive to think that that's beneficial to Bitcoin, and not something you would want to work towards. It is an indicator, hey, Bitcoin's becoming bigger, so they're taking interest, and they might value, some rogue state might really value the fact that they can hold on to some other money, great. But jurisdictional arbitrage is another issue, right? This has to do with if it's illegal to do mining or accepting of Bitcoin in some jurisdictions, which it is. Nigeria is one example. There's some other pretty heavy partial restrictions. Then people just move to other locations to mine or accept. Well, it's hard to move to another location to accept. Where you are is where you're accepting. So we tend to talk about mining in this sense. And the point I make is it doesn't matter where mining happens. The censor is the one who has the economic power to control majority hash rate. And it doesn't require a majority hash rate to control majority hash power. The number of cycles is not the only thing. We have pooling pressure and variance in terms of variance discount and proximity premium, which we talked about at length before. So with somewhere below majority hash rate, you can control censorship, and it doesn't matter where you are. So it's the economic censor that matters. It could be US, could be a number of other countries get together and say they want to preserve their signage premium, so they're going to get together and 51% attack the coin. So everybody else is going to be hiding. They may hide in some rogue state that allows them to do it, right? They're hiding from the permitting authority in some other state. That's great, but Bitcoin, doesn't inherently survive because of borders. That doesn't make any sense. It survives because if more people transact, there's enough people wanting to transact in it against the wish of the censor to pay for people to mine it against the wish of the censor. That fee premium, it's not the total amount of fees, it's only the amount of fees that's above the going censored fee rate. So one thing you might imagine is that, the feds in the US might come along and say, Bitcoin is great, everybody can do what they want. And then, then they decide they don't like certain transactions. It's already happening. They go to miners, you're a money launderer unless you only accept approved transactions. You're a money launderer unless you say Coinbase, you only accept approved transactions. And so you get this censorship regime, which is already starting to be imposed. And, it's the people that are not willing to accept those restrictions, black market people that end up paying higher fees. But the miners are getting fees from both sets of transactions. So the incentive for people to mine the illicit transactions is the additional amount of fees that's being paid. So that additional amount has to exceed the censors, the censoring miners' ability to extract tax revenue to subsidize it, right? Because if there's higher fees being paid by illegal transactions and they're not accepting them, they're going to mine at a loss, and that loss will be the amount of the total fee premium. And so you have to ask yourself, how much money are a set of states willing to tax in order to mine at a loss to offset, this anti-censorship? And some people would say, well, the price of the coin will drop and it'll collapse if they do that. And I'm like, well, that may be the point, right? That's not a security argument. Preserving the value of their fiat money, the ability to tax it is the point. Another thing you might consider is that when a state steps up and says, we love this Bitcoin thing, we only need these two changes to make it safe for everybody, and then you can do whatever you want. That actually may increase the price of the coin. That actually may lead to massive adoption and people loving it because they don't understand these principles. And so it's an error to assume that, some soft forking or some censorship regime or some hard forking inflation regime would actually decrease the economy. It might actually increase it. I think it would be almost self-evident that it would increase it in a for a lot of people. So the rest of us that want, actual Bitcoin will be, hiding. And that's the type of eventuality that I code for, because I really don't care, that Coinbase gets more customers or that the Federal Reserve is validating transactions. And that's just something people don't want to hear, but it's just the reality. It's just how it works. It's what it's for. And its security model is designed around that. It's not an opinion.
Yeah, it's definitely valid debate. Was wondering about Bob's opinion, because he was working on projects for Bitcoin custody for institutionals.
I'm not sure what the question is.
No question. There's no question. It's just an observation, right?
Yes, we can.
I mean, I put a question to you, Bob. If the SEC walked into Fidelity and said Bitcoin is money laundering, you can only hold certain transactions. You can only you have to accept our censorship regime. What would they do?
They would do it. They have to do whatever the government says.
Of course, they would do it. Yeah.
Right. And for the record, I no longer work for them.
You're not evil.
I know I do not speak for them, nor can I definitively say anything about. But I mean, just logically, any country-regulated entity has to do what that country says, right, within their borders, and states have the right to make those kind of laws. That's the end of the story, right?
So when we talk about resistance, people don't seem to ask themselves what they're resisting, right? Censorship resistance. You're not resisting, some 20% miner who decides they don't like your transactions, right?
Well,
somebody else will mine them. You're resisting somebody who's willing to operate at a loss to stop these things from happening. That's the state. And companies don't resist the state, not white market.
Companies do not.
And these are not opinions, right? And the Federal Reserve does not resist the state. So when people get excited about these things, I know they just don't really understand, what this is all about. And people don't want, they don't. I mean, there's certainly a large part of the community we all recognize that is in it as a casino, right? We're investing in Bitcoin. We're going to buy this thing, and it's going to magically go up in value. And anything that's big white market, Square, Coinbase going public, some central bank takes it. These are all good things because price go up. Price go up is great, don't get me wrong, but these are not contributing to the success of Bitcoin. The fact that they bring people in who might eventually figure things out, do some development, invest in some important things, that's helpful. You can't discount that. But building up infrastructure around these things, cash out.
So Gak points out in the chat, he says companies do fight against the state, and he's completely correct. And in many ways, having big companies on the side of Bitcoin is kind of the best ally we could possibly have. There's one thesis is that this isn't a bunch of hobbyists in their basement anymore. This is now big business. And when the SEC comes to Fidelity or any other large bank and says, "Oh, you have to shut down this business that you're earning, X number of $1 billion a year from," they're going to fight tooth and nail. And they do have lobbying departments, and they do have staff in Washington, D.C. for this purpose. Having them as allies, invested allies, right, is a great thing.
This is a, I see this as a classic argument, and Mike Hearn made this argument. You can't, he essentially made this argument that Bitcoin is a political money, right? In other words, if there's enough people that like it, they put pressure on the state and we'll still have it. That's what the dollar is, right? Political money has never worked. So it's the status quo. It's what we already have. So I don't see Bitcoin as a way to motivate people into voting for good money. Which, you can sue the state, right, because they violated some law. Then they change the law. You're suing them using their own courts, right? It's not resisting, right? It's political action. and political action. If people want good money, they simply have to vote for it. At least in Western democracies, we presumably could still do this. I'll also point out that people liked their gold, right? And it was very popular. And a lot of big companies, used it and held it in reserve. And the United States government, well, not really the government, the king at the time, signed an order that said, your gold is no longer money and we're taking it. And then the Congress backed them up on that within a year, and they did it. So when it becomes important enough to them, they don't even give a shit. So yeah, I see this as it's kind of a counterproductive thing to rely on a political argument for Bitcoin. If that's going to work, just go vote for better dollars. Bitcoin to me is a way for individuals to opt out.
Yeah.
Not to.
It's an opt-out mechanism, not a government control mechanism, right?
It's a way for people to say, I want to be able to transact privately, cheaply, easily, and without suffering inflation, and I want to do that without permission. And if everybody else wants
across national borders
to vote for bad dollars and to censor my Bitcoin, I'm still able to do it if enough people are willing to do it with me. It's an anarchy, not a democracy. That's the way I put it.
Good. Any questions or remarks to this? Okay, then thanks everybody. I will close the live stream now. We can still hang around a bit in the Jitsi and in VR. If someone wants to discuss something off the record. Thanks everybody for joining, and see you next time. Bye-bye.